Use Euler's method to approximate the solution to the given initial value problem at the points x equals 0.1, 0.2, up to 0.5 using step sizes of 0.1 given that dy dx equals y times 2 minus y, and that we're given this data point y of 0 equals 3, or in other words, if we're using x comma y, it would be 0 comma 3. So, as always, we can evaluate this using a table where we have n representing the number of iterations, x of n, and y of n to correspond with this value. So drawing these lines to make a table. The question previously stated that there are 5 iterations, so we go from n equals 0 to 1, 2, 3, 4, and 5. Now we are given the first values of x and y, so x of 0 and y of 0, which would be 0, 3. And we know that x of n plus 1, the following x value, equals the previous value x of n plus step size h. So if x is 0, x of 1 will equal x of 0, which we have as 0, plus h, which is 0.1. So 0 plus 0.1 is 0.1. Now x of 2 equals x of 1, which is 0.1, plus h, the same h as before, which is also 0.1. So 0.1 plus 0.1 equals 0.2, and 0.2 plus 0.1 equals 0.3, and so on and so forth. Now for y, we have to use this formula of y of n plus 1 equals the previous value y of n plus h times f prime of the previous values x of n comma y of n, where f prime is the same thing as dy dx, and we're just taking the previous iteration value. And fortunately for us, in this example, we don't even need to bother using x, it's just y. So to find y of 1, we need to take the previous value y of 0, which is given to be 3, plus h, 0.1, times f prime of x of n comma y of n, where this is the previous value of x and y. So plugging y of 0, which is 3, into this, we get 3 times 2 minus 3. And that's equal to 3 plus 0.1 times 3 times negative 1 is negative 3, and evaluating this gives you 2.7. So we know that the value of y as we go right on the coordinate plane is decreasing. Moving on, we now take y of 2, which is equal to y of 1, 2.7, plus h, 0.1, times now y of 1, which was 2.7, times 2 minus 2.7. And I'm just going to do this out in the calculator, where this gives you 2.511. So it's continuing to decrease. Following the same pattern, 2.511 is now added to h of 0.1 times 2.511 times 2 minus 2.511, and that gives you 2.3827. And you could round off probably to the 4th decimal, that's good enough. And now we take this value, y of 3, to find y of 4, where y of 4 equals 2.3827 plus 0.1 times dy dx, which is 2.3827, the previous value of y, times 2 minus 2.3827, giving you 2.2915. Now for the last iteration, n of 5, y of 5 equals the previous value of y, 2.2915, plus h times f of prime, which is y of the previous value, 2.2915, times 2 minus 2.2915. So now you can kind of get into the rhythm of this pattern. And our last value of y is 2.2247. And that is all you need to do for this problem. It's a great way of approximating values of ordinary differential equations, and if you have any questions on this approach or how I did this, please leave a comment below, and good luck.